This is the MATLAB code we were provided, and it plots a steady-state voltage input of 5 volts in two RC circuits. The thin red line represents the step input of 5 volts. The thick blue line is the RC circuit with the 10 kiloohm resistor, and the thick red line is the RC circuit with the 100 kiloohm resistor, both of which are approaching steady state. We can see that the 10 kiloohm blue line approaches steady state faster than the 100 kiloohm red line because it has a smaller time constant, since tau equals R times C, and the 10 kiloohms is smaller than the 100. This is my circuit with the 10 kiloohm resistor. Here's my Arduino code. In the setup, I declared pin 6 as an output, set it to 0, and held it for 5 seconds. Then I set the baud rate. In the loop, I set pin 6 to high and ran a for loop that holds this value for 10 times tau, which came out to be 1,000 milliseconds. Going through the loop, I read A2, which is Vin, and read A3, which is Vc. I communicated to the serial monitor to print the readings. Then I delay for 2 milliseconds, making our for loop iterate 500 times because 500 times 2 is 1,000 milliseconds. I then did another for loop applying 0 volts with all the same conditions. The serial monitor can be seen delaying for 5 seconds before running. And for the time interval where Vn is 5 volts, you can see Vn is near 1023 for the whole time interval, and the capacitor is charging up until it reaches around 1023. Then, when Vn is 0, the capacitor gradually discharges. In the processing code, I first changed the baud rate and port number. Then, for drawing the lines in text to make it look like an oscilloscope, I used the text and line commands. I first set the fill to be black, then used text size to set the size of the text. Then I named the text and set its position on the window with the text command. I did the same for the line command, giving it a start and stop position on the window. I did the same process for the 0 to 5 volts. Then for the key, I used the ellipse, fill, and text functions to position the circles at the top of the window with the text next to them. Then, when I run the processing, you can see how the capacitor is gradually increasing and charging up when Vn is 5, and then it gradually decreases when Vn is 0. This is my circuit for the 100 kiloohm resistor, and this is my MATLAB code. I just changed the value of R at the top. And then in processing, you can see it is slower to reach 5 volts when charging up than the 10 kiloohm resistor circuit was. And same for the gradual decrease to 0 when discharging. In my MATLAB code, I changed 3 things. The CSV file name, I converted the code to voltage, and then I also changed the y-axis data label. As you can see from this graph, Vc gradually increases charge to 5 volts, then gradually loses it when 0 volts is applied. In this code, all I changed was the value of R, and the tau value for the 10 kiloohm resistor was 1 second, but here we can see, because we're using 100 kiloohms, it's 10 seconds, as it's slower to charge to 5 volts and discharge to 0 volts. This is my circuit for the thermistor. The sensitivity is maximized when the resistance is even on either side of the voltage divider. So because from the datasheet RO is 10 kiloohms at room temperature, the resistor needs to be 10 kiloohms. In my Arduino code, I set the baud rate to 9600. I'm reading the voltage input and voltage output and printing it to the serial monitor. This is what the processing code looks like when it's run before any temperature differences. Now, when I increase the temperature with the hairdryer, the resistance of the thermistor goes down, which makes the voltage output decrease. And now, when I decrease the temperature with the ice cube, the resistance of the thermistor goes up, which makes the voltage output increase. I do believe the circuit behaves as intended, as there's a linear relationship between the cooling of the resistor, which makes both the ratio of the voltage divider and the output voltage increase gradually towards 5, and when it is heated, it makes both the ratio of the voltage divider and voltage output decrease gradually towards 0.